All right, Partha, let's begin. Where were we in our last class?
So we were doing coordinate geometry.
Yes. So we had actually begun with the coordinate geometry. We had covered the basic regions of it as well. And the last thing I remember doing with you guys is, we began circular measure. All right.
Yeah.
So we are going to continue on with that. So, for example, when we in our last class, when we covered circular measure, it was that we went through with, general form of the circle equation, and also, from that general form, what sort of information is already sort of like if a circle equation is given to you, what sort of information can already be obtained from the equation itself. Keeping this in mind, let's now continue on with this. So, whenever you're given a circle equation, also, one thing I've noticed student making the most number of mistakes in is the fact that, is the fact that, we've got r squared over here. I don't know why, but a lot of students seem to not misplace, I wouldn't say, but they seem to mistake this r squared as simply r, and that's wrong. So sometimes, whenever you're required to use the radius, or if he gives you a circle equation and asks you to find the area, obviously you're going to use the radius for pi r squared. But again, so technically, whatever is written in your circle equation, you have to directly put it over here in the formula for area. Why? Because r squared is clearly what you may call, it has already been provided in the circle equation. Whereas if you mistake it for simply r and if you square it over here, then that's just going to cause issues for you as well. Is this clear, person?
Yeah.
Now, moving forward, focusing on this more, what we're going to have is that we're going to look into what you may call radians. Now, when I mention radians, technically, what we're trying to say is that whenever we mention radians, oops, just a moment. Whenever we mention radians, we're trying hard to focus on tech. If we go for the very literal definition of what radians are, they are just another way, or just another way of measuring angles. So on your calculator as well, it says degree mode and radian mode. And what that is also, just ways to represent or express angles. Usually, we've seen from IGCSEs that we express angles in degrees. So, for example, if there's a triangle which has a 90-degree angle, we'll say it as like this as well. We'll say that the triangle has a 90-degree angle. So, we're
Yeah.
trying to measure it in terms of degrees. This is the same case as, like 9 centimeter, or like writing it down in 9 meter, or whatever it is. All right. So just alternative ways of measuring angles. So
Yeah.
it's just a way of expressing angles. So whenever we're writing down in radians, we're expressing angles. But obviously, because it is an alternative way of expressing angles, it's going to have some sort of alternative approach to it as well. It's not going to be identical to your degrees. Otherwise, why would we use a separate method to identify angles as well? So it's not going to be that 90 degrees is actually 90 radians. No, that's not the case. How do
It's
we get that?
4/2 radians.
Yeah. So it's just a way of expressing angles. And the only sort of, relationship that you need to know is that, or the scale to measure radians, the bond between radians and degrees is 180 degrees is equal to 1 pi radian. And radians are always expressed in terms of pi. Okay. Now, what is a radian? Technically, that's the question. Like, what if I were to define a radian to someone? What would it be? So, if I were to define what one radian is, it is the angle at the center of the circle, angle at the circle center, at the circle center, when the radius is equal to the arc length. When the radius is equal to the arc length. And what do we mean by that? Let's look at uh, a sort of an illustrative example. So, for example, angle at the center, circle center, when the radius is equal to the arc length, that is actually your radian. That's the angle that how it's forming. So, if I were to draw this down, I need a circle, and you'll be a better judge of this, but I think this is right. So, this is the circle center. Obviously, you're going to have radiuses using this, and it's going to be what? That
Mr. Radians basically comes
Mhm.
from radians, right?
Yeah. All right, Barsa.
Because like Mr. For example, when you want to find like the area of a sector or like the arc length, you use pi, and then if you want to convert from degrees to radians, you do like pi. You multiply by pi over 180.
Yes, yes. That's how you're going to do it. So first of all, if I were to define what radian is to you, it is when technically this is the angle that is forming. And what is one radian? That is what I'm trying to talk about. Like, what is the value of one radian? If I were to give you a scale or a way to measure one radian, it's going to be what? That one radian.
So 1 radian is 57.3 degrees.
Yes, one radian is equal to 57.3 degrees, but that's in terms of degrees. If I want to explain it in the way of, using a circle or the circle equation, it's going to be that one radian exists when your radius is equal to your arc length. This is, by the way, this is labeled as arc length. All right. S is a labeling for arc length. Is this clear, person?
Yeah.
All right. Keeping moving forward with this. So one radian is equal to one radian is actually or forms at the center of the circle when your radius is equal to the arc length. So you can say, if I were to explain like what is one radian equal to, it is the angle at the circle center when the radius is equal to the arc length. Now let's see. We already know this relationship as well. We've covered this relationship too, that it's going to be like this. For example, let's just highlight this down. And what we're going to try and do is that you're simply going to now this is the reference that you will use for any time you want to compare or use degrees and radians um interchangeably. All right. You just need to know that 180 degrees is equal to 1 radian, 1 pi radian, by the way. And one more thing, that it is always measured in terms of pi. So we are always measuring radians in terms of pi. So radians are actually where always expressed, or you can say in terms of. All right. So whenever we're trying to what you may call Mhm. All right. So radians are always measured in terms of pi, and the reason why that is the case. Now, a rough explanation of this could be the case that anything circular is going to have an influence of pi there. All right, we've seen volume and surface area in IGCSE as well, where when we used to go for calculation of volume and surface area and area and perimeter itself as well. That whenever there was some sort of a curved surface, you would seem to notice that pi was integrated into the equation or the formula itself as well. So that is going to be the case over here as well. Now, how are we going to use radians in our, when we're trying to find area and when we're trying to find arc length? Let's look at this. So I take a circle and I am going to, you know, draw what is a sector. So this is obviously, we already know that this is your radius. And we have prior information that this is your arc length. All right, we know that this is our arc length. Our arc length is always denoted by a lowercase s. Okay, let's see. Now, if you've got a circle, and obviously there's going to be an angle over here as well. So you're going to have some sort of angle, usually expressed in theta as theta, the unknown angle. Now let's see. So when I want to what you may call um, find out arc length, it's going to be denoted by a lowercase s. And now the formula that you guys were told, Pastor, do you remember the formula that we knew from IGCSE, how to find the arc length of a circle?
Yeah, it's 2 pi r theta over 360.
Yes. So
But
it
if
is.
you want, that's in when in degrees. But
Hmm.
um, if you do it in radians, um, 360 in 360 degree in radians is 2 pi. So 2 pi over 2 pi cancels out.
Hmm.
So it would be r times theta.
Perfect, Pastor. Absolutely perfect. So what's going to be the case is that we already know that 1 pi radian is equal to 180. And knowing this, we now know that it's going to be 2 pi radian when um, when the angle in degrees is 360 degrees. Keeping this in mind, what's going to happen? That it's going to be the arc length is going to be theta over, if I want to write it in terms of radians, it's going to be theta over 2 pi because 2 pi is equal to 360 degrees and you multiply it with 2 pi r. Now, what's going to happen? Your two pi's cancel out. So it's going to be this. It's going to be this. So your final formula becomes really basic and actually a bit more easier than the ones that you were taught in degree mode as well, which is that theta is equal to, oh, sorry, arc length is equal to r theta, your radius um, times theta. All right, Parth?
Okay.
That's the formula that you need to know for this. Keeping this in mind, what's going to happen is that next up we have area of a sector. So area of a sector is equal to. Now, if I want to find the area of a major or a minor sector, the formula was that area is equal to theta over 360 times pi r squared. Now that's again in degrees. When the angle was provided to you in degrees, that is when this theta was. That is when you used to have this formula. Now, if I again the same conversion is going to take place. 2 pi radian is equal to 360 degrees. I can copy down below over here as well. That it's going to be 2 pi radians is equal to 360 degrees. And what you're going to have is that the same area is going to be theta over 2 pi times pi r squared. So it's simply going to be the pi's again cancel out. So this time only the pi's will cancel out, not 2 pi. And what is your final answer is going to look like what you may
It's
call,
pi r squared over 2. I mean theta r squared over 2.
yes. So it's going to be 1 over 2 r squared theta. Clear, Parsa? Any
Yes.
issues with this?
No, sir, no issues.
Perfect. Keeping this in mind, let's continue. So that is how you find the area of a sector in radians. This is also in radians, and this is wait. Assalamu alaikum Nofal, how are you?
Walaikum salam, I'm good.
So this is in radians, and this is going to be in radians as well. Clear?
Yeah.
All right. Keeping this in mind, what's going to happen is that this sort of like wraps up your coordinate geometry um,
Yeah,
for
but
now.
the radians goes more into like trigonometry.
Yes, that is why if you're talking about, that is why I've specifically said that that wraps up coordinate geometry. We obviously, whatever you're being taught over here, one of the main reasons why a coordinate geometry question is very easy to attempt in the exam is because most of the stuff is being carried forward from your IGCSE. Most of the stuff that we've studied over here, like maybe even all of it has
No,
been
almost all of it. The only thing that's like new is equation of circle and radians.
yeah, almost all of it. Yeah, you apart that's absolutely right. And even like for example, if you took add math in O levels or IGCSE, you would have covered this as well. So this is one topic, one particular topic which students find. I would say that this is one topic that students should not lose marks in because of the fact that the and it's a topic that has never been left out. It's not something that the examiner might leave out, or it's something that's optional or might not come. No, that's not the case. It's a very favorite topic of the examiner. It's always there. So those 7 to 10 marks that you might get from attempting the coordinate geometry question, they should not be lost. You should not be losing marks there because this is probably one of the, if not the most easiest topics that there is going to be because most of the stuff has been carried forward. Now, the questions that are provided to you in coordinate geometry, I would say that, obviously the difficulty level that you faced in IGCSE, that's not going to be the same over here. You're going to have a bit more of an advanced level of difficulty as compared to your IGCSEs in coordinate geometry in A levels. Now, having said all of that, is there any questions regarding this, Nopal and Parsa?
Uh, no, sir, no questions.
Nopal, what about
No
you?
questions.
All right. Having said all of this and having done all of this, now I can safely move on to transformations. Before I do functions with you guys, I want to do transformations first.
Okay.
All right. Now, transformations are most of the transformations, just like coordinate geometry itself as well, they are going to be carried forward from what you've already studied in um
IGCSE.
yes. Yes. Now let's look at transformations. Now I'm going to use general transformations and I'm not going to be looking into specific examples. I'll be giving you guys general instructions how the graph might move and how changes to the graph occurs. All right. Just give me a moment, guys. Just a moment.